Thanks everyone for joining. My name is Dennis. I'm leading a team that's working on tooling in GridGain. Today we're going to talk about user authentication in distributed applications. We will take a look at different approaches to performing authentication in applications. So like we will start from simplest models until we'll keep increasing the complexity and convenience of this authentication models. Here at GridGain, we're working on a tool that's called GridGain Control Center that you can use to monitor your GridGain cluster. We will use that as an example of a system that has its own authentication system, and you can propagate information about authentication to the cluster itself. So we will consider that as an example of a system that has different points of authentication and can use some advantages of single sign-on and of distributed services. Here today also we have Alex Kozenkov, who basically detailed the implementation of integration with OpenID Connect in Control Center and did the biggest part of the slides. So basically I'm presenting his work today. So yeah, in case of any questions, he'll be able to help. Yeah, so let's get started and take a look at our agenda for today. As I said, first we will consider different authentication models that can be used in applications in both distributed and single-noded. We will take a look at like different approaches to this problem. The main point of focus today is going to be a single sign-on technology that helps us resolve some issues with different simpler and basic approaches. And we will consider GridGain with Control Center as an example of the system that can make use of the advantages that single sign-on provides. And during the demo, we will take a look at the ways how to integrate Control Center with OpenID, how to do single sign-on on the Control Center with the secured cluster, and we'll take a look how to make GridGain work with single sign-on with OpenID Connect, and yeah, we will look at the example of the implementation of the extension that you need to implement in GridGain in order for it to understand what OpenID Connect is. So let's start simple. We will look at the most basic authentication model that you can meet in production environments. For example, if you have a single noded application, it can store information about users in a local database where the business logic stores this information. So you can use the same database for storing both information about users and other information that's useful for your business logic. You don't need to implement any additional protocol for interaction with the user's database, and you can use the same database. It's really simple. Normally, when application developers start working on their applications, they start at this point, with the simplest approach, and after that, they when they hit other limitations, they increase the complexity of the system a little bit, but this is normally the simplest approach. But it's only good when you have one service, one application to authenticate. The things get a little bit harder as you increase the complexity of the system. If you have multiple services, each one of which need to have some information about users, about some to implement some authentication logic, you will get many databases with users, and you will need to take care of synchronization of these databases, and you won't get any global sessions in those multiple services. Like if you authenticate in one application, this session won't be present on our services. So you will need to go from one system to another and type in the credentials for the users. This is not that convenient, and those two problems don't let the users feel the convenience of your application. So one of the problems can be solved in a pretty straightforward way. We can just take all those databases and make just one of them, right? It's pretty straightforward and pretty simple. So you get rid of this problem with synchronization, because there is nothing to synchronize. You have just one point where you need to store the user information. If you insert the information about the users into that database, it appears everywhere. So it can be just like MySQL or Oracle database where you store information about users and other applications. All the services in your system use this database. This is quite popular approach, and it's pretty bad, to be honest, because the logic for authentication, like for checking the credentials, it's duplicated. It's multiplied in every service. You have this logic, and if you, for example, change the schema of the database, you need to make this change into the logic that works with this data in every service. So it's pretty inconvenient when you want to make changes to the way how you store user information. And yeah, the synchronization problem is solved. You can store information about sessions there, but like the logic is duplicated. You can't make the schema changes, and like you can't really add new untrusted applications to your infrastructure. You can't give access to your database to some unknown application. It may sound weird, like what does it mean giving information about your users to untrusted applications? But there are systems that allow this in a secure way, and it turns out that it's pretty convenient, and we will take a look at this a little bit later during our examples and the explanation. Or actually, like OpenID Connect supports this, and it turns out to be pretty convenient. So the improvement of this approach is to make not only the database of users, but actually to implement the service that works with the user's database. Like you can make a special authentication service with its own database and make every service in your application work with this authentication service. Here, the problem with the centralized storage is solved. The problem with you can probably implement the service in a way that will have distributed sessions, but you need to keep in mind that some special additional authentication protocol is required here, because it's not just a JDBC connection or whatever. It's like additional layer. It's like a special protocol that each of your application needs to understand. And like just like in the previous model, you have an additional hop that you need to do from your application to the authentication service in order to perform this authentication. If you care about performance, you may want to do some caching or something like that, so that you just need to keep in mind every application that does like a single sign-on or something like that has this drawback. So we are not going to solve it in any way. It's just like the thing to keep in mind that the performance may be a little bit worse in this scenario. Yeah, it's comparing to the first model we consider. Yeah, there is still a problem with the chained requests. Like, for example, if you make a request to the first system, and after that you need this system makes another request to another system, and each of those requests need to be authenticated in the system. For example, you may use LDAP for as an authentication protocol, and like in order for every system to check the authenticity of the user, we will need to perform a check of credentials that are passed with the request. This is actually a pretty popular approach, and it's also a pretty bad way to treat credentials, because you need to pass it along with the request, and if additional requests are done into other systems, then you need to pass the credentials along this request, and this is not a safe way to treat credentials. They may leak if you pass it from one system to another, and you can't include some external, not really trusted applications because they may steal your credentials. So it's pretty good for solving the synchronization problem, but it doesn't really address the distributed sessions. It doesn't do it in a secure way. So to solve this problem, the single sign-on technology was designed, and the idea here is pretty basic. The user won't pass the credentials along the request. It will communicate with the authentication service directly. It will just send the credentials to the authentication service. As a response for this authentication result, the application will get some token or a key that can be used to validate the authentication of the user in the system. And every request can now have not the credentials, but the key that was received from the authentication service. It's a much more secure way to treat credentials and do the distributed sessions. It solves the problem of centralized location of the user's database. It solves the problem of a single session for multiple applications, and you don't pass credentials with the requests themselves. They're only sent to an authentication service, and after that, only a temporary token is used instead of password. So let's take a closer look at single sign-on and see how they are implemented and what are the implementations of this technology. So the first implementation of OAuth, or maybe not first, but the most popular one is OAuth 2.0, and yeah, it was specifically designed to address this problem of distributed sessions and of users' authorization in distributed environments. Right? There are multiple flows in the specification. They can be used in different scenarios, like if you have a mobile application, or some of them are designed for front end, or some of them are made for acting as a user. So we will just consider only one of them, the most popular one, which is called Authorization code. It addresses the biggest number of scenarios, not all of them, but like it's a good trade-off, and it's the most popular one. So we will take a closer look at the flow of this authorization code in OAuth. Let's consider an example. for example, you have Facebook, which is going to be our authentication provider, the identity provider that will give the information about authentication and authorization. And we will consider an application that's doing photo editing. So as a user, you can go to the photo editor and you can request some pictures from your Facebook account. This is actually the scenario that was that the developers of OAuth kept in their mind when developing the this protocol. So it fits pretty well for this use case. So Facebook is going to be our identity provider. It will have pictures in the on the Facebook page that the user will want to download from the profile, and the backend, the photo editor, will need to retrieve that information from Facebook. So first thing the user will do, they will need to authenticate the photo, like authorized photo editor, to download pictures from their Facebook page. So the first thing is going to be a login request that was that is going to be sent to the photo editor login. After that, a redirection to Facebook is going to be performed by the backend, and you will see a login page of Facebook. You will be actually redirected to another website where you will need to type in your credentials. So you won't need to provide these credentials to the photo editor, but you will go to another website where you will need to authenticate and authorize your application that wants to download some information about you. Along this request, the client ID that identifies the application, a secret for this application, and the URI where Facebook will redirect the user after a successful or unsuccessful authentication. And also, other than that, scopes are going to be provided to Facebook. Scopes is the list of things that the photo editor is going to need from the profile of the user in Facebook. So the request includes the list of items that the user will need to give access for photo editor in their Facebook account. So this request is done, and after that the user authenticates in Facebook and approves the number of scopes that was requested by the application. After that, the Facebook sends back the authorization code, which is the why this flow is called authorization code. So if the authentication is successful, then success will be sent back. And after that, an exchange of tokens will be performed. Like access and refresh tokens are going to be provided to the photo editor application. After that, if some information needs to be retrieved from Facebook, this key is going to be accompanying this request, and this access token is going to be sent with the request for some information to Facebook. If this access token expires, because it's temporary, the application will be able to use the refresh token to refresh this access token. So when this information is received, the user is redirected back, and yeah, information about the photos are now at the backend. This is what you can observe actually when you authenticate in Stack Overflow, for example, through Facebook. Similar thing happens. You're sent to Facebook. You need to authenticate there and authorize Stack Overflow to access information from Facebook, your name, your email, and some other basic information. So every request to get photos will now be accompanied with the access token, and like this temporary token will be used during the request instead of credentials, so that the application itself won't even know about your username and password. That's why you can give access to untrusted applications because they don't really get any information about you, any credentials. They don't act on behalf of the user. They just get some information about the user. So OpenID Connect is another technology. It's built on top of OAuth, and it provides a number of additions. Like it's just an extension that provides not only authorization but authentication, except for the things that the application can do with the profile of the user in an external storage. It can provide also the information who this user is. Yeah, you can get some information about the user in a standardized way, and the specification of OpenID is more strict, so there's less variance in the things that are provided by the identity provider. So other than access and refresh token, we also receive the ID token that contains the information about the user that does the request. The ID token looks as follows. It's like a long string that doesn't make much sense from the first sight, but actually it's a JWT token that contains information about the user, and if you decrypt it, you will get the information about the user. There you will have the subject ID, which is the ID of the user in the provider's system, some information about name, about or first name, last name, the email, and some other information about the user itself, about the issuer. So this information is standardized, and it's provided in a secure way, and other than authorization, it provides this information, which means the authentication. So this is what OpenID Connect provides, and we will consider an example of using this with the Control Center. Recently, we released a version that supports OpenID Connect, and yeah, it makes use of this protocol to authenticate users through external OpenID Connect providers. Those who don't know about Control Center, it's a tool for monitoring and management for GridGain. So you can look at the state of your cluster. There are different setups. There is a hosted version on our public cloud. There is an on-premises version that you can download and make use in your private environment. And if you tried working with Web Console, this is a successor of it. It does basically the same thing, but better. We redesigned it. We added more features. It's much more stable, and it has better design. So if you're still using Web Console, consider switching to Control Center. It's just better, and it has support of single sign-on, and Web Console doesn't. So yeah, we're going to continue working on Control Center, and we're going to abandon Web Console at some point. Yeah, you can take a look at Control Center by the following address. The link will be in the slides. So Control Center, the dashboard looks like this. You can look at some metrics. You can make use of the tracing feature that was released recently in Apache Ignite. So you can look at the process that different operations in the cluster pass, and you can work with SQL, see running queries, you can see the statistics of operations, you can start queries, you can see explains for these queries, or you can take snapshots of your cluster, and all of that is supported for both Apache Ignite and GridGain. Like snapshots are not supported by Apache Ignite, but if you have GridGain Ultimate Edition, for example, then you can make use of snapshots. So it's great. You can take a look at it at Control GridGain Conf. So we're going to consider that as an example for single sign-on, because this system has its own authentication subsystem, and the cluster itself can also have a security subsystem. In GridGain Enterprise Edition, there is a security plugin that you can configure to work with some credentials, and you can configure it to work with like external identity providers, and we're going to consider that as an example for single sign-on. So our first demo will be showing the simplest model that we considered at the beginning of the presentation. We'll have Control Center with its own database of users, and GridGain will also have its own set of users, and those sets won't be the same. They will just use the same like different sets of users, and we will see what are the advantages or disadvantages of this system. So I'm going to switch to another screen, and here I have Control Center, which I'm going to start with just default configuration. I don't have any additional config here. It's going to start fresh. I don't have any users there. And we're going to start and to look at like what is the flow of users registration, of adding a cluster, and how we're going to authenticate in that cluster, given that the cluster has security configured there. So we can see that the Control Center started now, and we can go to our browser and open the local host where we have this Control Center installation. So this is the landing page, and to sign up there, we need to go to this form and fill it in with some information. So let's say we will use this email and some password. So we can sign up here and fill some missing some like information about ourselves, and here almost there. So yeah, we've registered. We don't have any clusters yet, and to add our first cluster, we will need to go to another tab, and here we will need to start GridGain Enterprise with configuration for security for the security provider. Right now, let's not focus on the specific configuration that we need to make in the cluster itself. Like we'll consider that a bit later. What we see is that it connects to Control Center, and it provides the token that can be used to add this cluster to the account that we've just created. So we go to Control Center now, and we click Add Cluster, and what we see is the authentication form. You need to specify the credentials that will be used to send to the cluster to make the authentication. The database of clusters, the database of users is actually different from the one that the Control Center has. So I can specify here anything. And even if the credentials match and I will be using exactly the same credentials, I actually have to insert like type them here again. So I will enter the same username and password, and then the cluster will be added. So this session is going to be temporary. Every time the session expires, I will need to type in those credentials again. But until the session expires, I will have access to all the features that Control Center provides. So I can see the metrics that are coming to the cluster, and I can go to the SQL screen and run some queries. So everything works, but if the session expires, then I will need to type those credentials again. So yeah, the storage of those credentials are those are different, and if I add a user to one storage, it doesn't mean that it will magically appear in another one. I will actually need to make sure that the same credentials exist in a different storage, which is like a pretty big disadvantage because you can't make your user management in one place. For example, if you have an employee who leaves the company and you need to invalidate their account, you need to go to every database and remove this entry from each database and not forget even one of them. And every time you need to authenticate in a different system, you need to type in those credentials again. And yeah, here we provide to Control Center some information about GridGain. So we specify the credentials that Control Center will need to send to GridGain. Like we can trust Control Center, but if it was some different application that we don't really trust, it wouldn't be a safe way to treat our credentials. So that's another drawback. If we want to improve our approach a little bit, we can integrate not with different databases. We will integrate with single storage of identity information. For example, Google can work as this identity provider. So Control Center can work with Google. GridGain can work with Google if you implement the authenticator in a proper way. So they will share the same set of credentials. Let's at this point not consider the single sign-on. Control Center will be integrated with Google over OpenID Connect, so single sign-on will be supported on the Control Center side. But let's now consider only the case with shared data storage about users, like a single authentication service, but without single sign-on. And let's see what are the like advantages and disadvantages of this system. I will shut everything down, and now what I'm going to do, I have like some configuration. I will need to do some configuration changes into my Control Center setup. I have prepared some configuration that will make it possible to work with Google. We will consider what are these configuration changes a little bit later, but now I'm starting Control Center with the ability to work with Google to do the authentication through Google, not with the internal data storage, but with an external one. So let's wait for Control Center to start. And after that, we'll be able to go to Control Center. Let's log out. And now if we go to the sign in and restart the page, we will see a button that suggests us to sign into this system using Google. So let's try doing that. We'll see a signing form, and here we will see some information about this application. This is the place where we are going to be redirected back, and like there's some information about the privacy policy or about the application itself, so we can take a look at that. And if we authenticate using our Google account, we're going to be redirected back to Control Center, where we are going to see the sign up form again, because some information from Google is missing. We received the first and last name, but currently we ask users to specify passwords as well for basic authentication. We're thinking about skipping this this step, because like maybe some users want just to register through Google but without specifying this password, but at this point we ask it. So let's fill in the missing information. Let's do that, and yeah, we're here again. It's our new account, and it doesn't have any clusters, so let's start another one. So this node will connect to Control Center again, and it provides the token that can be used to connect this cluster to Control Center. So we click Add Cluster and specify the connection token. And here we see the same form again, but the difference is that the storage that is used for authentication this time, it's the same that was used for authentication in Control Center. Even though this advantage exists, it doesn't really change the user experience much, because you need to type in your credentials once again. So I'm kind of repeating the same work again, and yeah, I'm there. The user experience is pretty much the same, except for the fact that I went to an external to an external system to authenticate. So it's pretty much the same. The session is already again started, and the the session token is stored on the back end and front end, but yeah, the difference from the first approach is that this storage is synchronized between GridGain and Control Center, but you still have this drawback with repetitive password requests, and you still need to send the credentials with the requests that are sent to GridGain, which is not that secure. It's not that convenient. So let's now consider finally the case with single sign-on, when we are going to authenticate in Google for Control Center, and after that we will make requests to GridGain using the access token that we are going to receive from Google. So let's shut down this cluster, and actually we won't need to make any changes to the configuration of the grid, because Control Center already uses the OpenID Connect protocol, and GridGain is already integrated with Google. It checks the it can check the access token when authenticating. So let's just log out, log in again using Google. This time we won't need to type in any information or any additional information, because this account already exists in Control Center. And now we will be able to go to the clusters, click Add Cluster, go to the logs of the node, and get the token, just like we did previously. Copy it to this field. And this time we won't use this, we won't specify the credentials, but we will use this feature that's provided by Control Center. It's authenticate via Google. It means that instead of actual credentials, an access token will be used that was received from Google during the authentication through OpenID Connect, through OpenID Connect protocol. So if we click OK, now we can see another cluster added to our account. And this time we didn't need to specify any credentials to Control Center at all. First we authenticated in Google and provided the credentials to the Google itself. And after that, we used the token to send requests to the cluster. And now we can do other requests as well. And the same token can be used to perform the actions. It's pretty convenient, and it doesn't require users to specify the credentials again and again. So let's return to the slides. Yeah, and we've already mentioned the advantages that we see. So the same set of users is used in both Control Center and GridGain, and you don't need to specify the credentials multiple times. What actually happens behind the scenes was already covered, but let's recap real quick. When an action request is sent to Control Center, it needs to authenticate at the provider to get the refresh and access tokens, and check if the access token is valid. Then the request with this access token is sent. If the access token is expired, then the refresh token is used to get another access token. When the request is sent to the cluster can use this access token to validate the session of the user. If it's still valid, then it can perform the action that was requested by the user and Control Center. If not, then it can return an error message. If everything is fine, then the response is sent back to Control Center, and user sees the result in the browser. So how the cluster does the check? First, when the security provider was implemented in GridGain in the cluster, we had this set of fields that can be specified during the authentication. Login, password, and the user object can be specified. Normally, login and password are used, but for cases like ours, we can use a user object and specify a token actually instead of the credentials. So login and password will be null in our case, and we will provide the token type and access token instead of that. In order for GridGain to understand this information, we actually need to provide an extension of GridGain, and it's available in GridGain Enterprise. You can provide your own implementation of the authenticator that will check the validity of the token that was provided from the Control Center. So you can see an example of such authenticator by the following link. It will be in the slides. Let's take a look on what is there. So if you go to this repository, you will see the example configuration that you need to provide to GridGain, and you will see the implementation of the authenticator, which is pretty straightforward. It implements the authenticator interface that is a part of GridGain library, and the main interface, the main method here is authenticate that does the checks. So we get the credentials here. We get login, password. If they're not null, then we use them to authenticate in the system. Otherwise, we get the user object, we get the access token and make a request to Google to check if the authentication is valid or not, and send information about we check the response code. If it's okay, then we think that this user is fine and can do all the stuff that was requested. There is no authorization in this code yet. Like we don't check which actions can be performed by which user, but it can be extended to support this as well. You will just need to change the implementation of the authenticate method and provide this implementation to GridGain. So this is how the extension of GridGain is done. And let's now consider what you need to do in your application in order to support OpenID Connect. And if you have your application that that is integrated, that supports OpenID Connect, how to register it in the provider, what needs to be done to make the provider understand, know your application. And we will consider Okta as an example. It's an authentication provider that supports OpenID Connect, and you can like register your application at this service and take the provide the information about the redirect URL, about where the user will be redirected after the successful or unsuccessful authentication, and provide some other information about your app. And it will give you the information that you will need to specify in your application in order for it to work with this authentication provider. So let's take a look at another quick demo that will consider working with Okta and the steps, the configuration steps that you need to perform to make it work with your application. So I've already registered Control Center here. It's just a part of my account at Okta. So this is a paid service that provides this OpenID Connect protocol, and it can be integrated with anything that supports OpenID Connect. So when you register your application at any OpenID provider, you will need to provide some information. Here I also specified the list of users that can be authenticated in the system using Okta. So only me is here on the list. On the general tab, you can find some basic information about the application. For example, which authentication flow is used. Here it's authorization code, and what is the redirect URL that is allowed. This is specific for Control Center, so you can specify it here. And what Okta will provide you, it's the client ID, client secret, and a few other additional configuration properties that you will need to specify in your application, in this case, Control Center. So let's make a configuration change in Control Center. I already prepared this configuration. So let's take a quick look at the configuration changes that need to be done. So here we can see a few properties that are specified. For Okta, we specified the client ID and client secret, which are the properties that are used to authenticate the application when an authentication request for a user is sent. So this is how we prove the authenticity of the application when a request is done to Okta. And also, we need to specify some information about the provider itself. It's some generic information about the provider, like what is the URI that needs to be used for authorization, or what is the address where to get tokens and where to send the refresh token. and what is the set of keys that are used for JWT. Because like JWT is an encrypted product, like format, and if everything is encrypted, you need to know the set of keys, of public keys that are used to decrypt this information, and it can be found by this link. So you can get all this information from Okta. This information is available in your application. It's specific for your application. For Google, the setup is a bit simpler because Spring already knows this information, like all these URIs are already known for Spring, so you don't need to specify. For Okta, you actually need to specify like client ID, client secret, just like for Google, and additional information like these URIs. So let's try to start Control Center with the changed configuration. So now we will have both integration with Google and with Okta, and users between those two systems will be matched by the email. So if you first register through Google and after that register through Okta, if different users, like if those two systems share users with the same email, they will be considered as a single user with this email, because like different users can't share the same email. So yeah, let's perform the same steps as we did before. So let's log out and refresh the sign in page. Now we have another icon here which says Okta, and we can go and authenticate here. So we can type in some information about our account, click sign in, and after that we will be, if everything is correct, we will be redirected back, and we will end up in the same account that we created using Google. But like this time, the difference is that if we use this connection token and try to authenticate via Okta, it won't work, because like cluster is integrated with Google, and a single access token that we received from Okta can't work with Google. So this time we will get the credentials, so we will have to specify the to actually specify the credentials. All right, so yeah, it worked this way. So yeah, let's recap what we've seen. The setup of this configuration is a little bit trickier. You need to register your application at the provider. You need to implement the support of OpenID Connect protocol, but the advantages overweight these things. Like the user management is more convenient. You can configure users and their rights in a single place. Yeah, the same credentials can be used for Control Center and the cluster, and you don't actually need to send those to any of those systems. You don't need to ask for passwords multiple times, and the sessions are encapsulated in the service provider, and this information doesn't leak outside. What we work with is just access and refresh tokens, and no additional information like username or password and the external system are used. So yeah, that's more or less it. For Control Center, we have the support of OpenID Connect, and you can sign in using Google or Microsoft. You can use your Skype account to authenticate in Control Center. At this point, GridGain doesn't have a like certified authenticator that can work with OpenID Connect or single sign-on, but you can use the one that is given as an example. So in some time, we are going to release the official one of the Authenticator, but currently you will need to use your custom one. And so maybe if users ask us to add more providers for the hosted version, maybe if users ask us to log in through LinkedIn, we may consider adding this ability. But at this point, we just support two of these providers. And LDAP integration is on its way. It doesn't provide any single sign-on, but it follows the like third model with a centralized authentication service, and it makes it possible to manage all the users in a centralized place in both Control Center and GridGain. So that's more or less it, what I wanted to talk about today. Thanks for your attention. Now I'm ready to answer your questions.
Awesome. Thanks, Dennis. We are running out of time, but maybe there's we can do one question. So one question is, if the external single sign-on provider goes down temporarily, what are some best practices to gracefully handle that situation?
Yeah, that's a good question. Like the centralized like provider, yeah, it has the drawback that it can go down, and then authentication in the whole system won't work. But like the providers work in a way that it's not just one node. It can be a system of nodes, so like it can have its own like different replicas. So if you have one instance of your Active Directory, for example, you can have multiple of them, so that if one node goes down, then you'll be able to work with another one. In case if you work with like Google, then yeah, it won't probably go down, but you rely on the internet connection. So yeah, you can reconfigure your application to work with like with a different authentication system. Maybe fall back to using some different user storage, but like in our case, we have our internal storage of users that we first like register through Google, and then we create an account in Control Center. So Control Center can actually give access to users that registered through Google, but those users are created inside Control Center. So that's one of the approaches in case if the centralized provider goes down. But like making a redundant copy of your provider is also a good idea.
All right. Thanks, Dennis. Thanks, everyone. Have a good day.
Yeah, thanks. Bye.
Yeah, bye.